1 inch underneath it. 1 inch to the left, 1 inch over it, you're going to feel heat coming off of it, correct? Now, what does this all mean to you? Real quick here, folks, here's your misconception. You'll go out and waste money on products for your home that do nothing for you. And here's why. You got winter, you got summer. Conduction, 7%, 7%. Convection is 45% in the winter, 0% in the summer. Radiation, 50% in the winter, 93% of all heat gain is coming from what?
Radiation.
Radiation. Again, take it from Isaac Newton, not from us. Thermal insulators such as insulation are materials specifically designed to reduce the flow of heat by limiting conduction, convection, or both. Radiant barriers are materials that reflect radiation, therefore reducing heat from radiation sources. A good insulator is not a good radiant barrier, and a good radiant barrier is not a good insulator. So in fact, what did he tell you you needed in your home?
Both.
Both. What do you have now?
One.
And which one don't you have?
You do not have the radiant.
Where is your largest amount of heat lost?
Right at the radiant.
So, according to him, which one is going to stop that radiant heat? The radiant barrier. What is a radiant barrier? Okay, at this point, I'm going to put these in your hand. There's radiant barriers.
Oh, okay.
Okay? What are they? Now, I want you to take a look here. Okay, when I started this, you'll notice, what's the temperature of this one here?
About 80.
And this one here is about the same?
Yeah.
Okay? Now, what I want you to do is take a look at that in about 5 minutes. Because if you look at top of this, do you see a difference? This one's got just insulation.
And that just has the barrier.
Okay, and it has the barrier there. Okay? But let's take a look at this. Clark E. Beck from Wright-Patterson Air Force Base first picked up radiant barriers at the request of NASA. And what he found that a thin sheet of aluminum radiant barrier would do the same job as a 7-foot thick piece of conventional insulation. The 1948 Popular Science that was published in. Okay? Now, notice this bottom line. There has been great resistance to radiant barriers by lobbyists for the insulation companies to keep them off the market. Let me ask you this. If every person in Nevada knew that insulation could only stop 7% of their problem, how many people in the South would continue to buy insulation? Do you understand why they spent billions on lobbyists? To make sure you don't know that it can't solve your biggest problem. That's why. So, if we take a look, what do these things cost? Okay, and before, you ever heard of Dallas Morning News, Dallas, Texas? Big newspaper? Okay. You got 3 pieces here. There's a radiant barrier. Okay? What's that made of?
Oh my God. Cardboard.
Cardboard. Okay?
Huh.
So if it rains and you get
Right.
moisture, what happens to cardboard when it gets damp or wet?
Goodbye.
Okay? And you don't ever get any storms through here that produce wind, right?
Oh no.
Because they take this and they staple it to your rafters, and the air coming up through your soffit, what just happened to that?
I know. Oh my God.
Where's it going to end up once air comes up through?
In your neighbor's yard.
Actually inside, just be all over the floor. And you'll notice that there's a difference in its structural integrity. Okay? And actually, we are competing against